Normally I go over with you actually some of the problems on the worksheet, but because there's so few problems on this worksheet, I want to make sure you got a chance to practice by yourself. So instead what I'm going to do is just go over the first couple of rules here. So we're talking about functions in Unit 6. So in the first one we have several different types. We have linear functions, we have proportional functions, which if you remember is a form of linear function, inversely proportional functions, and quadratic functions. I'm just going to talk about linear and quadratic here because the worksheet asks you, is it linear, or is it quadratic, or is it neither? Okay, so you should have already gone over this rules, but I'm just going to point out a few things. So the parent function for linear is y equals x. And what that means is that for every x, y is going to be the same exact value. And the line, it forms a straight line. So now every line, though, this is the parent function, but every line has just an x, has a y and an x in it, or in some cases you might have a y equals some number, which would also be linear. Inversely proportional, we're not going to really talk about right now, but just to remind you what those are the ones where we have y equals 1 over x, and they basically look like this. Obviously those are not linear. Quadratics, to be quadratic, they have to have an x square in them. And no x cubes, nothing higher than that, but they do have to have an x square. And so they form a parabola. It's kind of like a U. It keeps going out and out and out, but they tend to get narrower and narrower towards the top. And they form an x squared. So this is, again, the simplest one, the parent function, which is y equals x squared. They can be more complicated than that, and we'll go over that in just a second, but they all do have to have an x squared in them. So in this case, just whatever x is, y would be that squared. So negative 2 squared is 4. Alright, so when you look at the graphs, basically if it forms a line, it's linear. If it forms a parabola, it's quadratic. If it forms any other shape, it's neither. When you look at the equations, if it's got an x in it, not one that's in the bottom of a fraction, not one that is with a square root, which would be something else, but just an x in it, then it is linear. If it's got an x squared, it is quadratic. If it has anything else going on with x, x cubed, x at the bottom of a fraction, x under a square root sign, it's going to be neither linear or quadratic. To be able to tell from a table, though, well, one thing you could do is you could just graph it. If you just graph it, then you could tell if it was linear or quadratic. But there's another way we can do it. We've been working in the past, especially with linear functions, with delta y and delta x for slope. But if you remember, right at the beginning of linear functions, we talked about if delta x is the same, if x is going up the same every single time, then if it's a line, y is going to be going up the same every single time. So this is going up by 2, this is going up by 2, this is going up by 2. So these form a line. Now, in quadratic functions, let's take a look at what happens here. So these are x is going up by the same. So if it were a line, these would be going up by the same. But let's see what they do. So this is going up by 3. It's going up by 5. This is going up by 7. Now if we take a look at how much these go up, though, this goes up by 2, This goes up by 2. We call the first one, the first set of differences, the first difference. We call the second set of differences the second difference. In a quadratic equation, or quadratic function, the second difference is going to be the same. So if you look at a table, the way you tell is you just do delta y, you do the first difference. If they're the same, then they're aligned. If they're not, check for the second difference. And if the second differences are the same, then it's going to be quadratic. If neither the first differences or the second differences are the same, then it's neither linear nor quadratic. Alright, so here is worksheet 1. Like I said, I'm not going to do any of these with you because there's so few. I really do want you to practice. But just remember, on the ones on top, if it forms a line, it's linear. If it forms a parabola, it's quadratic. And if it forms any other shape, it's neither. On these, take a look back at your rule again. If it's got an x with nothing done to it, except for maybe multiplied, then it is linear. If it's got an x squared, it's quadratic. If it's anything else, it's neither. And on the tables, we need to take a look at our first differences and our second differences to be able to tell. For the next section, I actually want you to create your own. I'm not going to give you much of a hint here. I would like you, I mean, you can do a real simple one that was already up there, but I would challenge you to do something a little bit more difficult or a little more challenging. But if you can go find linear and you just go y equals and then something that would be linear, just take a look back at your rules, and then create the table for that, and then create enough points to be able to see what that graph would look like. Then something that is quadratic, just take a look back at your rules, and then something which would be neither linear nor quadratic.